Writing shader is fucking hard. In this tutorial, you will learn to create gorgeous sky with shader script in Unity. Our sky does not interact with light. So we will write vertex and fragment shader. Right click on project panel and create onlit shader. Name it sky shader. Now again, right click on project panel and create new material. Give it a name sky1 or whatever you want. In the material inspector, select sky shader we have created, which you will find in onlit shader submenu in shader tab. In the hierarchy panel, create a sphere. Apply sky1 material to it. Now sphere should look like giant white sun. Double click the sky shader and it should open VS Code. Does this shader script looks scary to you? Don't worry.
Be happy.
We will look it step by step. In Unity, shaders can be written in two different ways. Surface shaders, which are affected by lights and shadows. Vertex and fragment shaders, which doesn't need to interact with lighting. The shader command contains a string with the name of the shader. You can use / character to place your shader in submenus when selecting your shader in the material inspector. Let's change it to BioStudios/Sky Shader. After saving, if you go back to Unity and see the material inspector, you should notice that the material is now placed under BioStudios submenu. The properties block contains shader variables like textures, colors, etc. that will be saved as part of the material and displayed in the material inspector. Let's add three colors: color A, color B, and color C. Let's define color property called color A and assign its default value white. Similarly, define color B and color C as well for overhead sky, horizon sky, and below horizon sky. Save the shader file and go back to Unity. On the material inspector, now you have three different color properties to assign, but it does nothing yet. Let's look at subshader. A shader can contain one or more subshaders, which are primarily used to implement shaders for different GPU capabilities. In this tutorial, our shader will contain just one subshader. Each subshader is composed of a number of passes, and each pass contains vertex and fragment code for the object that contains the same shader. And the real magic happens between HSL command, CG program, and endcg. Pragma vertex tells that the code contains a vertex program which runs on each vertex of the 3D model but does nothing visible, whereas pragma fragment runs on every pixel that object occupies on the screen. Vertex shader takes vertex position and texture coordinate as an input. Vertex to fragment structure named V2F is defined to pass position and texture coordinate parameters to fragment program. Woo! Finally, it's time to define data type to our colors from property block. Define float for data type to all three colors. Vertex program is defined by vert function. Here, vertex position and UV transform is computed to return as output O, which is used as input data in fragment program. Let's see what happens if we return color A. Sweet! Now we are able to change color from the inspector. Let's written lerp between lerp from color A to color B by interpolation 1, and let's see how it works. Lerp is not working. Let's use UV as interpolation and see what happens. We are getting an error. We need to lerp interpolation to UV's Y direction. It's working, but the colors are in reverse order. Let's fix this by simply flipping the UV coordinate in Y direction. You might have a pretty good idea by now, but it's impossible to lerp between three colors just using a lerp function. UV coordinate is a range between 0 and 1. If you can remember coordinate geometry from your 5th grade, it's much easier to understand UV coordinate. Assuming you know coordinate geometry, UV coordinate is the first quadrant of this square. UV coordinate in X and Y directions are bound from 0 to 1. We need to lerp from color A to color B and color B to color C. If we divide UV in equal half, the midpoint will be 0.5, which means we need to apply color from 0 to 0.5 and 0.5 one in y-axis of UV. If J is smaller than 0.5, lerp from color A to color B, else lerp from color B to color C. Multiply the interpolation by 2 in both lerp. Gradient sphere is working. Let's scale it up as big as the sky's gone. Let's bring it back. Adding call front should fix the backface calling problem. Our sky's back. Now duplicate the material and apply to multiple spheres. I know it's lame, but limit is the sky. I'm still learning, but I hope it's helpful.